Welcome to tonight's video on calculating circuit loads. This is part of our putting it all together activity, and we're focusing on how to do the calculations with regards to this sheet where we've got these interesting little tables that are trying to help us figure out how much current is going through any of our color-coded circuits so that we can make sure we don't trip too many. Let's get started. The goal is to group outlets and lights so that no circuit is likely to go over 15 amps. It's not going to be a guarantee, but that's the target. We aim for less than 12 amps just so there's a little bit of extra room. So after you've got a circuit grouped by color, so you've gone through and you said, okay, I'm going to use this particular color. So let's say I'm going to go through this color and say, okay, I'm going to put, if I've got an outlet here, and I got another outlet that's further down the thing, and I know that those two circuits our outlets are close by, and I say, well, I'm going to run a wire to there, run a wire to there. And you don't have to show how the wiring works inside this switch because the expectation around previous work is that you know how to do that. Then it's going to go on to whatever else is going on. So let's see what you're going to have to do. You're going to first add the wattages of all the appliances that are plugged into those outlets. You're then going to, once you have the total amount of watts, you're going to divide by 110 volts to get the current that's going through that wire. And then if you're under 12 amps, you're all good. You don't need to change anything for this circuit. If it's over 12 amps, you're going to select something to move on to a different circuit. And then you're going to look at those other circuits that were under 12 amps and say, okay, can I slide something that uses a certain amount of power over onto that one to make some space? So that's how it's going to work. If you find that you've just got too much power needs, you might have to just put in an extra circuit, but remember, you don't want to put too many in because that increases your cost. We're going to move on in 3, 2, 1. Okay, so we're going to do a little practice here. I made a little drawing off the side here so I can give you an example. So that chart, remember, it had loads, number, the power, something called group power, which means if there's more than one of them, I can multiply the number of them times the power that they use. Okay, so what I'm going to do is I'm just going to sketch out a basic floor plan here. I'm going to start here, go down, across, no space here, do that. Okay, so what I've sketched out is essentially something that looks a little bit like my parents' living room. I got a window here and we got a window here. And I'm just going to draw in what they have. And to emphasize what they've got, I'm going to use green. No, I'll draw them in black. So there's an outlet down here. And that's a little longer. There's an outlet on this wall. And there's an outlet over here. Just at the time, they were really careful to not put outlets underneath windows typically. So you'd often find outlets on either sides of windows, but not on both. You'd find them often on both sides, but you'd rarely find one underneath. And there's an outlet there. And I believe that was it. Okay, so those are all the outlets in my parents' house on that side. And on the other side of this wall, there's an outlet here, which I'm going to use for illustrative purposes here. So these are windows. Oh, sorry. These are windows. Okay. Now I'm doing a little bit of a kind of a blending here of the two drawings. So if this was drawing B, I'd have the walls, I'd see the windows, I'd see all the electrical outlets here, and I wouldn't see any of the furniture. So I'm going to change colors here, and I'm just going to put in some of the things that would be in here. So I'm just going to put in here that I'm going to use a 24-inch TV, and we got a stereo, and we have a 100-watt lamp, and there's another 100-watt lamp, and over here there's a 100-watt lamp, And here they wanted a 150 watt lamp. And that's all that's in their living room. But on this side, there's a fridge. So if this is what's going to be my purple circuit, what I'd be drawing is I'd be saying, okay, well, I'm going to go from here to there, around the wall, down and down and down and across and back to this side. And wherever the electrical panel is, let's pretend the electrical panel was on a wall over here someplace, and you'll see the symbol for electrical panel. I'd have to have this purple wire going back to the panel someplace. So it doesn't matter which end starts or ends of the panel, it's fine. In my parents' house, there are no lights on the walls or on the ceiling for their living room. Every bit of lighting is plugged into an outlet, so I don't show any of those. So let's look at the loads that I've got here. I've got, and okay, that's my black. So in this room, and we've got a fridge. There's just one of them, and the power usage for that is 900, and everything in this is in watts, so I don't have to keep writing the watts. So 1 times 900 is 900. Lamps. There's 3 that are 100, and there's 1 that's 150. So 3 times 100 is 300. 1 times 150 is 150. And then there's that TV. There's one of them, and I think I looked it up as 200 watts. So that's 200. And the stereo. Again, there's one of them at 220. And I'm just pulling these wattages off a worksheet I'm going to give you that gives you some typical values. So at this point, that's everything that's on the circuit. Total power I get by adding up everything in here. So it's the 900, the 300, the 150, the 200, and the 220. I add all those up and I get 1,770 watts. To get the current, I'm going to divide by 110 volts. And when I divide the 1,770 by 110, what I get is 16.1 amps. Now, 16.1 amps that's bad. Because remember, I've got to keep it under 15 and preferably under 12. So what would I do at this point? I would say, well, that fridge really shouldn't have been on there. So I'm going to take this fridge out. So I'm going to take the fridge off of here. And now my new, if I take the fridge out, that's 900 off of this, which means my new power is going to be only 870 watts. When I divide by 110, I get 7.9 amps, and that's good. So moving that fridge off the circuit, so what I would be then doing is I would be trying to erase, and I'm going to totally mess this up now, but if you've been copying this, you've got this. Yeah, I just messed up and took out walls and all kinds of stuff there. So I'm going to leave that outlet there. And what's going to happen is I'm going to put my purple back going through all of those. But notice I'm going to not go to that one. And I'm going to have to pick a different circuit. So this will be my purple circuit. And then maybe I'll be using a different color like this orange. And maybe there will be a wire going over just to that fridge, and that way I can have my fridge on a dedicated circuit, which is best anyway. All right, so that's the kind of thing we're going to be doing with that, and it's going to take a little practice, and you'll get there. All right, thanks for watching.